Hi guys, I've just made this video just to really help you with worksheet number 4, which is really about finding the equation of the graphs where there's a horizontal shift. So I'm just going to work from question 7 and just look for those horizontal shifts. So what I'm doing is I'm going to look at the graph and I'm going to find a period. So I can see here that the equation is tending towards the sine. It wants me to do a sine. So I need to look for where a sine starts and finishes. So I'm going to go here and here. They are not my only options, but for me, the easiest one. Now, normally a sine graph begins at 0 and goes up to the amplitude. Well, you can see here that it's not beginning at 0. My period's beginning at a shift along in this direction. And what we need to know is how big that shift is. The next thing we need to do is work out what the period is. So let's just look at that shift first of all. We can see on the scale here it's pi over 3. Well, half of pi over 3 is pi over 6. So there's been a pi over 6 shift this way. And because it's gone in a positive direction, we're going to have a minus pi upon 6. So C in our equation here will be minus pi upon 6. Okay? Well, that's what we're going to put in there. So it'll be a x minus pi upon 6. Now, let's work out that period. Well, it goes from here all the way to just 1 square past the 2 pi, and the normal regular period of sine is 2 pi. So we know that the period is 2 pi and it hasn't changed. Let's look at the amplitude. The amplitude from here up to here, so obviously we can establish the equilibrium position is the x-axis, so therefore d is 0. So from there, the amplitude is 1 to 2.5. Now, I prefer fractions. I don't like decimals. Obviously, if you want to write 2.5, you can. It's correct, but I'm going to write 5 over 2. And now what I'm going to do is substitute these values back into the equation to give me that equation, which is y equals 5 over 2 sine x minus pi over 6. Okay? All right, let's have a look at, let's have a look at a second one where there's a horizontal shift. Number 9. Again, we're going to follow the same process. We're looking at a cos function here. So what I need to do is look at the graph and find the beginning and the end of a cos graph. Cos, if you remember, begins at the top of the amplitude and comes down. So I'm going to go for this one here. Let's go here to here. Again, it's not the only option. And what I need to do is establish what or how far away it's gone from this position to here in the x direction. Obviously, it's gone in that direction, so it's going to be a minus again, like question 7. So if I have a look, we can see that this is 1. So each of these is 0.2, 0.4, 0.6. There's been a 0.6 shift, which again, I prefer fractions. That's 2/5. Okay, so the shift C is going to be a negative 2 over 5. Okay. Hang on a sec, that's 3 over 5. Apologies, that's me just being silly. 3 over 5. All right, now, the next thing I need to do is work out how big the period is. So, going from here to here, I'm going to count. So I've got, in each one's worth 1/5. So 1, 2, 3, 4, 5 over 5, which is 1 whole. So the period is 1 whole thing. So I need to work out what the value of b is for that one. So we put that into our formula. 2 pi over b equals 1. So therefore, 2 pi equals b. So our value of b is 2 pi. The equilibrium position we can see is the x-axis again. So we could calculate the amplitude, and the amplitude is just 1. So there's been no change of amplitude. So therefore, a is 1. And d is 0. So subbing those values back into the formula, we get the equation as y equals cos 2 pi, open bracket, x minus 3/5. Now you might be thinking that's not the only cos graph. You might think, well, I picked a different position for cos. Let me just give you another example of how we can get a slightly different formula, but it's still correct. So let me just show you where I could have started the cos graph. I could have begun negative cos, but it's hard for me to read what that value is on the x-axis, so I'm not going to do that. I could have also taken one period of cos to go from here to here. Now, if I'd have done that, what you're seeing now is that the shift has gone this way. Actually, let me draw that line up where it would normally start. It would normally start here, and it's gone this way to that point there. And what we can see is because it's gone left, it's a positive value of c, so there's a plus c, and we work out that it's gone back 2/5 in that direction. Nothing else has changed. The period's still 1, A is still 1, and D is still 0. So I can actually get an alternative cos formula that looks like this, which is cos 2 pi of x plus 2/5. Now, both of these answers are correct. Let me just do one more. This is question 10. All right, so now, first thing I'm going to see is there's been a vertical shift. So I need to find where's that equilibrium position. So I'm physically drawing that on the graph here. And I can see that the equilibrium position is at -2. So I'm going to write that D equals -2. I can see it's a cos graph. So I want to find out where does cos start for what I'm going to do. I'm going to start it here. Starts at the amplitude, comes down up to here. That's one cycle of cos. And what I need to do is work out how far it has shifted. Now, because it's shifted, it would normally start here. It's shifted to here. I need to calculate how far that's shifted. Well, I can see that it's at this point here. So that's half of pi upon 2, which is pi upon 4. So I'm going to put minus pi upon 4 in there for C. There we go. I need to calculate the period now. So let's have a look. Normal period of cos is 2 pi. Well, I can see that there's 2 pi and it's gone one place this way. Well, it's one place from that way. So the period is still 2 pi. So the value of B is still 1. Okay? And then lastly, the amplitude. Well, the amplitude from the equilibrium position is 1. So therefore, A is 1. Sub those values into the formula and we get the equation to be y equals cos x minus pi upon 4. And then don't forget that value of D minus 2. And as I showed you in the last or the previous question, there are other answers to this. When there has been a horizontal shift, there are potentially 4 different equations that you can find with different horizontal shifts, and they are all correct. 2 of them would be sine, 2 of them would be cos. In fact, I make an error there. There are more than 4 because, of course, you can then consider the negative cos and the negative sine. Okay, so pretty much what you want to be doing is just finding one and then checking your answers with my answers at the bottom. If it's slightly different, just have a look. What's the horizontal shift that I've got, and can you see that yours is also correct? All right, there's only one more question on the exercise that's got a horizontal shift. So this is question 12, so I'll just work through this one. So we can see it's cos we're looking at here. So find where cos begins and ends. Here and here will do. We can also see there's been a vertical shift, so find your equilibrium position, which is here. So the value of D is 2. So I'll write that, D is 2. Now let's have a look at the horizontal shift. Cos would normally start here. It's here, so it's gone in this direction, and it's gone 3 places that way. So because it's gone that in the positive direction, it's a negative. We're going to have a minus C here, so C is minus 3. Let's look at the period now. The period starts at 3, goes to 11. So we have the period as 8. So let's work out the value of B. So we go 8 equals 2 pi over B. 8B equals 2 pi. Therefore, B equals 2 pi divided by 8, which is pi upon 4. Finally, I look at the amplitude. And we can see the amplitude is just 1. So A is 1, so there's been no change of amplitude there. Sub those values into the formula and you get y equals cos pi upon 4, bracket x minus 3 plus 2. Hopefully that gives you a bit more help with the horizontal shift.